Welcome to this video to extend the discussion on quality measurement instruments and particularly relate those instrument design to specific types of validation and assessment of reliability. So we're going to remember from previous discussion that performance on survey items or any kind of test items, and I'll use test generally to represent any kind of measurement, should allow valid inferences about test takers' perceptions of the construct. So each item, each survey is supposed to present an unbiased opportunity for the congruence of the response and the attitude measured. So in the video or in the image, what you see is this survey item, survey scale, test item, whatever it is, and it's supposed to be a transparent interface representing people's true, unseeable level of the construct measured to the way a test maker or interpreter is going to interpret that. So we always, with self-report, not so much an achievement test, but with self-report, we always have the problem of what's called reactivity. So this is when thinking about what one thinks, reflecting on the content of the item changes the response. And this could be due to specific things in the item content. It could be due to thinking about the person who is asking the survey questions, the interface experience, anything really besides what one is supposed to be thinking about, which is the construct. And this could come into the way items are written, the vocabulary used in items. It could be due to other things about the way the items are written, such as the cognitive complexity. For instance, if people are really asked to think about two different things at the same time. I like my teachers and I appreciate the attention they pay to my needs. Well, you're thinking about whether or not you like them and whether or not they pay attention to your needs. You might feel differently about those two different things. That should not be asked in a single item. Whether test takers actually have mental access to that. If a test taker has never asked for attention to an individual need, if they've always kind of gone along with the class and not thought, I need something special, then they're going to make something up if they really want to answer the question. They have nothing to refer to. And non-contingent responding is that you want good item writing, you want appropriate cognitive complexity, you want people to be able to retrieve the information, and you want their response not to be contingent on something else, like getting some kind of reward for responding. So those are all desirable things that can reduce reactivity. Sorry about that repetition. Careless responding is something that just people do when taking surveys. Most individuals have done this at some time. And this is just, the test taker isn't even paying attention really to the content. They're choosing down the middle because they don't really want to think that hard. So that's called sitting on the fence. They're answering randomly just to get through the process. Or they're skipping items. They're answering 2 out of 5 items, and then if it's an online survey, they're clicking ahead. If it's a paper and pencil survey, they're turning the page. And we want to avoid that. There are many ways to try to avoid that in survey construction. There are more sophisticated and less sophisticated ways. There are also ways to try to detect it after a survey has been constructed, so that unfortunately you discard the responses of people who have done these things, which means you lose your sample size, but you really want to have valid responses. So there are lots of ways. The most common way during item construction, that is prior to administering a survey, is to use negative items. So items that have a negative valence in comparison to the others. Items where, so if most items represent positive thinking about the construct, then you'll have some items that represent negative thinking, which would be construed as the opposite of positive thinking. So this first item, things never work out the way I want them to, would be construed as opposite to optimism or pessimism. I always look on the bright side of things would be construed as optimism. So if you were measuring optimism, we would say that the first item was a negative item. And so you would expect that a person who responds in the same way to both of these items was demonstrating careless responding. Now, the problem with this, a lot of people nowadays aren't really fond of negative items or very careful about their use. They need to be, it's important that they actually are equivalent in meaning, that a person essentially cannot feel both ways simultaneously. They could not respond at the positive end legitimately to both statements. So if you look at this example, a person could say, things never work out the way I want them to. Yeah, that's pretty true, because I've had a lot of bad luck in my history. I always look on the bright side, yeah, because part of my attitude, my personality is resilience. So they could answer positively to both, in which case the idea that this negative item is inconsistently valenced is what they call it. So it's kind of opposite. The positive one is not holding up. And that's a problem with negative items. And as I said, there are a lot of other ways that people look at careless responding. But if you're reading in the literature and people say they're using negatively worded items, that's what they're referring to. So now we're going to get to, you've constructed this instrument. A person in the literature you're reading has constructed this instrument. And now they're going to, or they drafted it anyway, and they're going to assess its quality. And what they're going to do in terms of assessing its quality, the things that you will most commonly read in a paper on instruments, or sometimes just an excerpt from the measurement section in a published article, is that they're going to assess the validity and particularly if it's the development of an instrument, and they are going to assess its reliability. So how should or how might they report that? The most common things you would see, you will see other approaches, but I'm going to emphasize here the common things to look for in a measurement article, or to do if you're creating your own instrument. They're going to look for, they're going to do some content validation. That would particularly be if they're developing the instrument. They also, if the instrument is in development, they may do some construct validation in terms of what we call substantive processes. Show that in a minute. Structural evidence, which would be internal or external, and they should always report reliability, whether it's measurement development or just reporting it in a published article as something they use. So looking at each of those, content validation is an approach to simple judgmental review of the content of the items presented on the survey or test. And in developing an instrument, always what a person should start with is decision about the construct to be measured and definition of the construct. Okay. Stating out this is how the construct is defined for the purpose of this measurement. Then, based on the theory of the construct, they should create a kind of a list of ways that that construct could be operationalized. So these are behaviors that one might see visible if a person has behavioral empathy, which I think is part of some definitions of empathy. These are a list of feelings that a person might express that they see when they look at an image. So that's cognitive empathy. You see someone crying, you understand that that person is sad. That sort of thing is actually used with very small children very commonly. And then once you have this, then you base those, the actual items, maybe a whole series of images of people's faces showing different expressions with, you know, a list of moods that that person might be experiencing, and the child is asked to assign a mood to the picture. Those are items. Each picture is an item. It's a prompt. And then you have judges review the appropriateness of that content. Okay. Does it cover the way that the construct has been operationalized? Is each item or stimulus relevant to that construct? And the way we do that a lot of times is with sorting tasks. So you see here, this was a survey of grading beliefs. We had what we called a factor in this case that was a kind of grading beliefs. We've defined it as grading to reward or punish behavior. So kind of the construct overall is management, classroom conduct, orientation to grading. This is the big definition. And then we have one sample item that that is an operationalization of that item. What would it look like for someone to support this management attitude? And you see item 1, 4, 8, 12, and 15. There are 5 items with similar vignettes. And what we did, this is actually a paper that I wrote with Professor Peggy Chen, is after we had all these items, the original survey had 26 or something, we actually cut them out on little slips of paper and we gave them to experts. And we said, sort these 26 items according to what you think, you know, kind of clusters, create clusters. Okay, I'm going to put 4 items that I think are similar in this cluster. I'm going to put 5 items that I think are similar in meaning in this. Sometimes we had them name the clusters. Sometimes we gave them already. We have what we think are items related to use of grading to reward or punish behavior. Which items belong to that? So those are all alignment tasks to see whether or not the content of your items is fitting the way you've operationalized the construct. And you could just give, if you were just looking at a unidimensional factor, you could just give 15 items and say, is there any item or items that don't seem to fit in meaning or are ambiguous? Okay, so that's a kind of content validation. In a measurement development paper that focuses on how a measurement was created, you would expect to see this. Construct validation can be done in many ways. Okay, so there are a lot of approaches. The one on this image relates to what we call substantive process construct validation. And it's kind of how and does the method actually stimulate the responses that indicate the construct. So what are people perceiving or experiencing while they're responding to this survey? Do they actually have access? Are they thinking, I don't really know what this means. I haven't had this experience. What should I say? I guess if I would have this experience, that would be, as I call it before, erroneous response. I can't remember what I called it before. And are there things that they're thinking about that are constructive health? So for this, we use what are called cognitive labs. And they can be, what were you thinking about while you took your test? Would be retrospective. It's not a great method. Concurrent think alouds, okay? Talk through this test. What are you thinking? Just articulate your thinking as you're doing this test. Heartbeat, eye movement, all kinds of things go into cognitive labs. There's an increasingly large literature on cognitive labs in measurement development. So that's one approach to construct validation. You would not see that in many papers, but in test development, you will sometimes see it. And then very common approaches to validation are looking at structural evidence, both what we call internal structural evidence and external structural evidence. And these are a little bit harder to describe, but I'm just going to talk you through this image, which is what we call a table of factor loadings. Okay, so with this grading belief survey, Professor Chen and I hypothesized that this instrument we would develop would cover 3 approaches to grading. One of them was management, one of them was an effort orientation, and I think one of them was leniency on a case-by-case basis, giving somebody a break. I actually had a graduate student who referred to this as mercy grading. And you see, this is an image that shows what we call factor loadings. Don't necessarily need to know what a factor loading is. If this is a video for like a general research methods class, you would not have studied this. If it were a measurement class, you would. But you can think of factor loadings as analogous to the correlation of an individual item with this latent thing. You don't know what it is. It's a factor. It's how strong is the relationship between this item and the how we call it loading. How much of that item variance can it be explained by one thing? And so you see, you're looking for values to say that you have a meaningful factor loading above like 0.5. You're supposed to have some values that are above 0.6 or so. And you'll see the loading for Ms. Fort, which is 0.384, is kind of small, but you have at least 5 items that have meaningful magnitude of relationships to this factor 1. We don't know what factor 1 is. Maybe it's management, maybe it's effort. We have to look at the content of those items before we assign a meaning, but they all cluster. Then we have factor 2, which is pretty clearly related to items 15, 12, 6 to 9, 7, and 19. And so those I've blocked out so you can't see those. I'm sorry, there was a little interruption. I have blocked out the loadings that are we call them non-salient. They're close to 0. So what they're telling us, the ones, for instance, under the first factor, starting with Mr. Davidoff, is that they're going to be near zero. So they don't seem to have any much of a relationship, those items, to the items that have factor loadings above 0.38. So the top items seem to cluster on one factor and none of the other ones do. And that's true with factor 2. So the ones that related to the first factor don't have, they're all close to zero. I've blocked them out just to make it easier to see. And in factor 3, you see only that those 5 items load on the third factor. None of the other items really have an appreciable relationship to the third factor. So we would say that the structure, the internal structure, because this is all one test, it's internal to the survey, has 3 apparent factors. It's a 3-dimensional test. Okay, now we have now set that up as we thought we designed the test in that way. We tried to design the test in that way. We approached the content validity as the test had 3 dimensions. We had named the dimensions. And now let's say that we've checked with the content of these items and they do seem to fit. So then we can actually test that. And this is a way that such a test would look. This has only got 2 of these factors. I'm not going to show more, but you see we have factor 1 and factor 2. The number of items are different than they were on the previous display, but we have 2 factors. We've hypothesized a 2-factor model. And this is what it looks like, or what it should look like if it's what we call a good fit. The items that we predict will be related to factor 1, statistically show evidence that they are. The items that we predict will be related to factor 2, show statistical tendency to relate to a different factor. The double-headed arrow at the top, you can see over on the right that indicates that the 2 factors, factor 1 and factor 2, are related to each other. Maybe, probably, you would hope not a huge amount, but they are related. F1 and F2 are called latent factors. They're called latent because we can't see them. We have to look at the items to interpret them. That's all hypothetical. The factor loadings are those same numbers that we saw in the columns on the last side. And that means that you would just fill in numbers next to each of those arrows. Items are the items on the actual survey. And that bottom row is error terms, which just mean every individual item. The factor can explain all of the variability in the items. They all have little kind of funky things that is going to make people answer differently. And so you always have those little error terms at the bottom. Okay, so that's internal structural evidence, which will usually start with the factor analysis. And so you may look in a paper that's published to see whether or not, if they claimed that an instrument measured something with multiple dimensions. So I say I have this survey of grading beliefs and it measures 2 or 3 different aspects of grading beliefs, and it's composed of all of these items. Then I've actually tested to see or analyze the data to see if statistically that holds up, that the items that I think are going to relate to, say, management, do relate to one factor, and the items that I think are going to relate to effort do relate to effort. So that's internal structural evidence, and it's a way of looking at the validity of the test, because you made this claim about the structure and you're evaluating. Now, this is going to blow your mind. Perhaps, but this is what's called a structural equation model. And as you see in the name, structural equation model, it again looks for structural evidence. And there are a lot of ways to look for information about external validity, and not all papers you read will use this structural equation model. It's called CFA. But if they use it, one of the nice things about it is it actually statistically tests the factor structure of the scale that you're using, or the scales. And that's along the left-hand side. That's where it's traditionally written. And so you can see that there are 5 latent factors, and they're kind of in the middle. Latent factors are always written within circles. And they are the source, the mental underlying latent source for responses to all of these 14 items. So items 1, 2, 3, you can barely see this. They all relate to attitude. And this is the hypothesized structure. And then this can actually be tested to see whether or not it meets certain criteria that would say, yeah, this is the right structure. Then all the way on the left, you see the error terms. You don't really need to pay attention to those. But in boxes, because they're actually measured variables, you see, oh, we have 3 items that load on this thing that we're calling attitude. Factor 1, we're hypothesizing that's attitude. Then you have 3 more items that load on something else. 3 more items that seem to load on knowledge. No. 3 more items that I don't know what they load on. It's like PDC. And then 2 items that I believe load on subjective norms. So now, so that's the first 3 columns of images. That's your measurement model. That's just like the one on the previous, minute or two that had the 2-factor model, right? So that's confirming the internal structure of the test we did before. What goes then to external is that you have this measurement of another latent variable. And it is measured all the way on the right by 3 items. So it has its own little measurement model so that you know that intention has some internal structural evidence. And where you're getting at external structure, bear with me, is these arrows relating the correlations. Actually, they are not bidirectional. I'm sorry, my note in here is incorrect, but these should be monodirectional arrows pointing from, for instance, attitude to that 4th to the right circle intention. So that indicates a relationship between attitude and intention, between health and intention, knowledge and intention, PDC and attention, and norms and attention. So where this is called external structural evidence is because, again, we're assuming that we have made a hypothesis that part of the identity of the, I shouldn't say identity, part of the nature of these 5 things that we have measured, that we have pretty much demonstrated now, our instrument measures, is that they will be correlated with intention to do something. And now, if this model holds up, yes, they do. So our claim about the external structure a claim, this is really getting into the claim about what have we measured. Before we've said, oh, the internal structure seems to have 5 models, five factors, and you look at the content and you say, oh, this is how I'm going to identify the factors. But you're really not really. It's just a lot of it is just based on the internal qualities. So now you're going to say, if those really are the things, they should predict something else, something that I hypothesize. This actually is a theory called the theory of planned behaviors is all demonstrated here. And the whole thing is that these things like attitudes and subjective norms will cause intention. And if they did not, then either your measurement is wrong or your theory is wrong. And so this is really important because this structural equation modeling can both show you information about the measurement that you've made and its relationship to other variables, which is part of its validation. Okay. Then we're going to go on to, I believe that's all the approaches to validation that are going to be in this presentation. Just a quick refresher. During instrument development, if you were developing an instrument, or a person who was developing an instrument who were reporting on the development, would be expected to start with the construct, the general definition of that, theory-based operationalization of that, careful item construction to minimize reactivity and careless responding, and content validation. Giving the items to expert judges to see whether the content of the item is appropriate to the way the construct is operationalized. That's data-free. Then you're going to go into probably, if you are creating an instrument or if you are reading a development article, possibly substantive process validation, where you would look at, okay, are these items reactive? Are people thinking about the sort of thing I want them to be thinking? If I'm measuring reading comprehension, are they in fact using like scanning instead of reading top to bottom, which may or may not be something you consider part of reading comprehension. But if that's what you're looking for, then are people using that method? So you're going to look at that as you are kind of a pre-pilot, or an author might be looking at that. That's not kind of uniform across all test construction. And then they're going to field test the actual item. And at that point, they're going to undoubtedly look at internal structural evidence if they are positing that they have an instrument that measures more than one distinct dimension, kind of sub-construct within that construct. And they should do at least an exploratory factor analysis and describe the results. They, depending on the level of development of the test, they may confirm that structure by testing, and that would be reported as a confirmatory factor analysis. And they may go on to a structural equations model where they relate the structure of their instrument to other instruments, or they may just take scores from that instrument and show correlations with other related variables, which would be as if I didn't have all of these boxes in here. In this image for the structural evidence, I simply had the circles, and those were representing survey scores I wasn't trying to test. I'd already tested the structure, the internal structure of each of those, and I wasn't going to do it again. And so I was just relating attitude to health, to knowledge, to norms, and to intention. And each of those was considered a piece of external structural evidence. So you can kind of chop this into bits, this current image. You could say, oh, the analysis of attitude, health, knowledge, whatever that thing is, and norms, all those 3 columns to the right, those are all internal structural evidence through factor analysis. And then the area that's just all circles is external structural evidence without bothering to include internal structural evidence. And that would be what we call convergent validity, but it's part of external validity. All right. Now, a little bit more. Any report of a measurement instrument should include report of its reliability. The 2 most common things that you would see reported or that you would be expected to report yourself are internal consistency and, in some cases, inter-rater reliability. So to start with internal consistency, that is most often reported as Cronbach's alpha. It's being seen more often that it's also reported as a coefficient called omega. Just going to talk about Cronbach's alpha. That's the most commonly reported term. And it represents generally the degree to which variability in scores within a single scale is correlated among all items on that scale. So an individual item, does it relate strongly to the other items about management? Are the intercorrelations among the management items all positive and moderately strong? That will give you a high internal consistency. The rough guidelines for what means to be high is that in the 0.60 range, 0.60 to 0.69, a instrument is considered to have okay reliability. I've definitely seen things published. I think I've published myself with something in the high 50s, but that's not very good. 0.70 to 0.79 is considered pretty much fine. Anything greater than 0.080 is very good. And so those are just guidelines. They're very rough, but they're very common in the field. So it's something to look for in a published paper. It's something to aspire to if you're trying to develop something. If you have a multi-factor instrument, multi-dimensional, like the management effort, etc., survey of grading beliefs, each scale should be assessed for its reliability. Okay, not the overall measure, because the overall measure is not for a single dimension. You do not expect all the management items to be correlated with the effort items. You expect the management items to be correlated with one another and the effort items to be correlated with one another. And so each should have its own internal consistency. So you want to look for that. And I believe last is we do a different kind of reliability analysis when you're using an observation protocol. An observation protocol is generally going to be developed and validated according to pretty much similar methods that were used in everything else. Probably not a factor analysis. There should be some kind of convergent validity evidence, but you know, particularly with content validation, there should be a theory of the construct, you know, quality instruction, and the relationship between each behavior to be observed and what it means to have quality instruction should be evaluated by expert judges. If you have something that's going to be important to people's careers, like teacher evaluation, you want to have good expert judges. You want to be able to document their expertise. There should be several of them, not just a couple. The other thing we look for that is pretty much unique in observations, also like essay assessment, is what we call intra-rater or rater reliability. The first subset of this, which is less commonly assessed, is intra-rater. So say you have 50 videos of instructional behavior, and you have one of your raters, and you may have all of your raters do this, but one rater takes these things in order from 1 to 50 and rates them each. Now, the people running this observation study to assess intra-rater reliability will shuffle the videos and have it done again. Or, because that's a whole lot of cognitive load on the reviewers, they will, they're in the 1 through 50, they will insert the first one twice. Or they'll insert the fifth one twice or 3 times. So they'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 videos evaluated 5. 11, 12, 13, 14, 15, 16, 17, 5 appears again. And that's to find out whether that rater would give a consistent value, judgment, scores on those behaviors to the same video. Presumably, they've kind of forgotten the video by now. They've been doing a lot of ratings, and so they're looking at it again, freshly, pseudo-freshly, and would they give it the same scores? So that's within rater consistency or reliability. An intra-rater is when you give multiple raters the same packet of videos, or you have them in the same room for the same observation time in different corners, and you see whether or not they provide the same ratings, and you assess both of those according to percent agreement. And obviously you want higher agreement than lower. You also do this in qualitative analysis with coding usually, but that's a different story. So these are the common methods that you would see in reporting different quality descriptions of instruments. You'll see fewer of them in an instrument section that is just reported as part of a study. You should definitely see Chromebox Alpha, but more of them if you're studying an actual paper that reports on the development and validation of a particular instrument, or of course, if you're doing it yourself with your own instrument. I hope this was useful, and see you next time.